Hi everyone, this is Mr. Martis. Hope you're all having a great Easter weekend. This video is in lieu of the Monday night class. On Monday night, you all voted, and it seemed like everybody, it was like a unanimous, that we wouldn't come in on Monday night and we would do stuff remote. So this will be broken up into different sections. First thing I'm going to do is make this video due on Delta Math by Tuesday night at Tuesday afternoon at 4 o'clock. That way you don't have to give this class any attention unless you want to or you're behind um, until Tuesday. So this will free you up for a full Monday. The topic of this week, like I mentioned in class last week, is vectors. Vectors is something we haven't talked on. Vectors is something, if you've Googled or spent any time on the internet, you've probably seen plenty of vector type material. In computer science, we initially teach you all how to use arrays, and for the most part, we continue to use arrays, but in the real world, it seems like the trend is more people transitioning to using vectors just because of ease of use and to take advantage of the standard template library, which is available on C++. Standard template library, STL, is referred to quite often, and we're going to use some of its functions today. All right. A vector is a more powerful array, right? There's certain things you can do with a vector that you can't do with array. If you remember some of the messy things with arrays, you couldn't make an array longer easily, right? You dynamically allocate memory for an array, and that's what you've got to work with. Copying it over is also a problem because you have to copy it over one element at a time, right? Using a for loop. So it kind of gets cumbersome sometimes using an array. All right, let's just dive right into vectors. And you can see right here, the only thing I need to use is include the vector. All right, so we're going to have two preprocessor directives and the usual using namespace standard. All right, first thing I want to do is I want to make a vector. All right, I'm going to make a vector. Oh, I'm sorry, I already had one made here. All right, I'm going to make an integer vector. We're going to keep things simple. You can make this with chars, arrays. You can make a vector of just about anything, just like you could an array of any different type of things like strings, chars, structs. I mean, you can do this with anything. All right, so I'm going to make a vector, and I'm making an integer vector. I'm going to name it v and make it 3 elements long. Now, there's different ways you can enter things into a vector. And you can use, for the first thing, the one I use most often is because of my background with using arrays, is I just use array notation. In this array, v3, I went ahead and signed 3 elements values, v0, v subscript 0, 3, v1, 5, and v2, 9. Right? Some of the things you can do, the things that the standard library gives you. Right? The first one is we can use the size if we want to know the size of a vector. Right? Vector's name is v, and I hit a dot, and this shows you some of the things that the standard template library provides. I'm only going to go through just a portion of these things. Look at all these. All right, it provides these up front with no additional programming. All right, so it's a pretty powerful thing to use. In this case, I'm just going to use the size function. I want to know how long my vector is. So I'm just going to see out v.size endl. Okay, you can see right there, it's 3 elements long. Right. I'm going to go up here before I move on. Let me erase this. I'm going to make another vector. Vector. I'm going to also make this one an integer. I think everything we deal with today on this video will be integers just for simplicity. Let's make this W. All right, notice I didn't tell it any length or assign anything. Right? Right now, we've got a totally empty vector named, which we named W, that is empty. If I did a size right now, W.size, it would give us a 0. All right, there's different ways I can enter it other than what you saw up here with notation, with array notation. I can, first of all, I can make a vector of size 5. All right, that's the first thing I can do. That's size 5. It doesn't have any values in it, or if it might have garbage in it. Yeah, I mean, but it has no real value right now. Another way I can do this is I can use the curly brackets and assign values of 2, 4, 6, 8, and 10. Okay, so there's different ways we can do this. All right, I already showed you this, how to use the size. We need a print function, so we're able to look at these. All right, I've already made one down here that I'll copy and paste up there. I'm not going to use prototypes for the simplicity of this lecture. I'm just going to go up and put the print function right above main. Now we can use it. Let's talk about it for a second. I'm going to send it. It's a void because it's a print function. Almost all print functions are void. All right. I'm going to send it an integer vector. And inside of my function, I'm going to call it a vect. All right. Now, I'm just going to go through a for loop and go through that vector and print out everything. I've got this unsigned int I equals 0. This would probably work with int I equals 0, but it's best in this case to make it unsigned, which makes it positive. All right. That kind of deals with, because we're using size, and the size has to be a positive number. I mean, you can't be a negative height. You can't be a negative weight. All right. So we're going to make this unsigned int I equals 0. Then just loop through it I through vector size. Whatever we send it, standard template library is going to do the size of it and use that for the upper bounds. Then I++, then it's going to print out using array notation vect I. All right. So let's look how this would work. To print it out, after you get the print function, I'm just going to send it a vector and have it print out. So this first one is 359. There it is. If I wanted to print out W, there's W. Right. So I'm going to keep deleting this stuff because I want to talk about everything one at a time. So let's talk about one of our first commands that the standard template library allows us to do. I'm going to talk about a pushback. Okay, pushback And I'm going to give it a number. Oops, I forgot. All right. I got v dot pushback 13. What that does is it adds an element at the back of your vector and puts a 13 in it. So now we got vector 0 equals 3, vector 1 equals 5, vector 2 equals 9, vector 3 equals 13. This is a big, this is like awesome because with a regular array, you can't just plop an element at the back of it if you want it to be longer. So this is a really important thing. So now if I want to print this, push 13, I'm going to print out V. Right, there's all 4 elements. So pushback's probably the one that I use the most. All right, some of the other commands that you'll use. I want to see what's at the front of my queue, or I mean at the front of my vector. So I'm going to see out front. So at the front of my vector is a 3. And if I want to see what's at the back of it, I just change this front to back. And there's the 9. Remember, this is my initial array, not the one I added. I pushed back to 13 at the end. All right, if you don't like array notation, you can use the at notation. At notation does just about the same thing as the array notation. So if I want to do v dot at 0, which is the first element, right, then I want to see out the 0. The at will let you do exactly the same thing as the array notation. So this should give me a 3 for both of these numbers. So there's a 3 for both. Pop back, all right? If you wanted to delete the very last element in the vector, pop back's what you want to use. So I want to go v dot pop back. I'll just go straight and print it out to show you that it works. All right, pop back, I run it. And it's got rid of the 9 at the end. There's the 3 and the 5. It got rid of the element at the end. Now it's a 2-element array. I'm sorry, a 2-element vector after I pop that off. All right, you've got a clear function. Right now, since I'm erasing these as I go along, we're back to the original vector of 3, 5, and 9 for v. V dot clear. Then I want to go print v. When you start playing with this, which I strongly suggest, I strongly suggest you just don't watch this video. And I would sit there, watch this video, and take some notes, actually practice some of this stuff on the way through. Hit debugger. So I'm totally clearing out V, deleting all. V's still there, but but now I'm going to take it from it's V. It's 3 elements long. Now it's going to be V, still there, but it's got 0 elements in it. The clear emptied out the 3 elements. So also, if I wanted to use the size now, cout v dot size. So you can see v is 0 now. Okay, empty is a way of checking an array to see if it's empty. So I'm going to go back. We know after I ran that, v is empty. So if v dot empty, so if it is empty, it's going to be true. If it's not, it's going to be false. So we know it's empty. I'm going to put, if it's empty, it's going to cout vector is empty. Right. So an empty function is something you may use. This might be a good time to mention. I'm trying to give you like a starter kit on this. I am going to make an assignment that's going to ask you to do a few things that it's not on the sheet. And the research of this is as simple as I don't know what I did. I think the assignment's got something insert at the beginning. Finding out how to do that is as simple as putting in the search engine, how do I enter something at the beginning of a vector, right? I want you all to actually look this stuff up. I think there's 2 or 3 things. There's going to be like 10 or 11 tasks in the program that I'm going to assign. 2 or 3 of them I didn't bother, and it was intentional of showing you on this video or any other video. I want you to go in and research it. And research, it's not like pouring through pages. It's as much as just using the search engine. All right. Not sure if I showed you this a few minutes ago. I'm going to show again. All right. I'm going to make an integer vector. I'm going to make this one called D. I'm going to make it 5 long. And I want to go ahead and assign it a value. All right. To assign it a value, I'm going to go ahead right here. I put a second number inside of the parentheses. Right. Now I've went ahead and assigned, let's do something better than 0. I'm going to go ahead and just put a 7 in each one of the elements. So it's 5 long, all right? And I'm going to go ahead and put a value inside of each one of the elements. So it's D, so I want to print D. So you can see 7 elements long. Let's see, I want to make a new vector with another vector's contents. So let's go back up here and see what I've made. I've made V and W. So I'm going to make a brand new vector. Let's call this one F. And I want to make it with, let's say, these contents. So I've got a new vector. It's F. And I just made it I made it an exact copy of V. So let's print this out just to check it. Print V. 3, 5, and 9. So right there, I printed out V, which whoops, I'm sorry, that was a mistake on my part. I want to print out F, okay? I made F with the contents of V, so I want to print out F. And there it is, 3, 5, and 9. I want to get rid of these. And I got one more I want to show you because I've actually used this, and this has actually been kind of handy at times. I'm going to take, let's see what I made up here. It's this W and V, I think. Yep, I've got a vector W and I got a vector V. And the standard template library provides something that's called swap. So I'm going to take my W vector and I'm going to swap it with V. And I don't know why I hit go because it's not going to show anything. All right. So now let's print out. We're going to print out V. Do it like this. See out. V. Oh, just do this. Okay, remember, print V is going to print out now because we swapped was what was in W. So this should print out 2, 4, 6, 8, 10. All right, that's sort of my beginner's take on standard template library and vectors, right? There's going to be stuff, like I said, there's going to be things you're going to have to research, right? Some of it, I would suggest you go in and check out some of the options. I hit V dot and just look at this: pushback, size, begin, clear. A few of these, there's the at, back, beginning, C beginning. I'm pretty sure you might be using the C beginning in your assignment. All right. Look at all the things. I have not used all of these. Some of them I don't know what they do. Right. I'd encourage you to go in and play with it. My experience has been that students actually like working with vectors. They're easy, they're fun, right? And they're pretty much more intuitive than just working with arrays. All right, again, this video is going to be due by Tuesday at 4 o'clock. I'll go ahead and make it 6 o'clock. Tuesday at 6 o'clock. All right, you have to have watched it and answered the questions. There will be an assignment coming a little bit later in the week. Let's say the video is due by Tuesday at 6 o'clock, and I'll put up an assignment sometime before Wednesday. If I get a chance, I'll get to it as soon as possible. All right, if you got any questions, you can contact me. Either email address. I'm getting pretty good at checking my Thomas More as much as my Boone County address. All right, guys, have a good rest of the weekend. And just to recap, next Monday, we're going to do a review for the final exam, which is the next week. So we're down to 2 weeks left in the semester. All right, have a good rest of your weekend.